Section 9.3, the normal distribution. So now we're going to put the standard deviation into order. So if you look at, we've got three different curves. We have the A, a B curve, and a C curve. And no matter what, doesn't matter how steep they are, how shallow they are, they all have the same properties. The peak occurs directly above the mean. And we remember from last lesson we used this little symbol to represent the mean. The curve is symmetric about the vertical line through the mean. So if you were to fold your paper in half, about here, it would be symmetric on either side. The curve never touches the x-axis. It extends indefinitely in both directions. So it's going to get super close to the x-axis, but never actually touch it. The area under the curve is always equal to 1. So this agrees with the fact that the sum of the probabilities in any distribution is 1. So the probability of something happening plus the probability of something not happening is equivalent to 1. The horizontal axis of the standard normal curve is usually labeled z. So we're going to label our x-axis z. Find the following areas under the standard normal curve. So we're going to need to use Appendix C in the back of our book. So let's find the area to the left. And any time that we are finding z-score, it's automatically shaded to the left. So we're okay with it being shaded to the left. So what I need you to do is, you'll notice when you go back to the back on appendix that on the left-hand side, we don't have hundredths, we just have tenths. So I want you to find 1.2 in the left-hand column, and then we're going to match that with 0.05 on the top. So where those two meet together would be 1.25, right? And where those two meet each other is 0.8944, is where the left hand and the top column collide together. So that means that we have 0.8944, and the area to the left here, this is shaded. Okay. So let's find the area to the right of z equals 1.25. So this time we're looking to the right. It's automatically shaded to the left-hand side, so to find the right-hand side, since the entire area underneath is equivalent to 1, we can take 1 and subtract. We already found that the z-score of 1.25 is 0.8944. So if we subtract that, we'll get 0.1056. So the area to the right is now shaded. So this little piece here is shaded. Let's find the area between the z-score of negative 1.02 and 0.92. So our goal is to find this area in between these two z-scores. So let's start with z equals negative 1.02. So on the left-hand side, you're going to look for negative 1 on the left, and then pair that with 0.02 on the top. And where they collide, you will see it's 0.1539. So this is going to be the area to the left, just as an example. So let's look at the z-score of 0.92. We need to find 0.9 on the left and match that with 0.02 on the top. And you'll see they collide at 0.8212. And again, this is the area to the left. So we have a bunch of shaded areas to the left-hand side. To find the area in between, all we need to do is take 0.8212 from our z-score of 0.92 and subtract our first z-score, so 0.1539. And when we subtract, we get 0.6673. So that is our area in between here that we can shade. Okay. Let's find another area on the left-hand side. So we want to find, we have z equals negative 0.76, and again, it's automatically already shaded to the left. So we want to look for negative 0.7 on the left-hand side, and then match that with 0.06 on top. Notice that 0.7 and 0.06 when combined is 0.76. And we'll see that they collide at 0.2236. Since it's already shaded, it's going to be kind of closer to this way, I suppose. And this is just a guesstimation. It's not a perfect science, I guess, but 22% would be further to the left-hand side, and as we move to the right-hand side, it gets closer to 1. So find the area to the right. So now we have to think about to the right since it's automatically shaded to the left. So we're going to look for negative 1.3 on the left of our column, and then 0.06 on top. We'll see that they collide at 0.0869. And remember, that is being shaded on the left, so over here. We want the stuff on the right-hand side. So to get the stuff on the right-hand side, remember we subtract. So we have the whole thing is 1, and we subtract 0.0869 to get 0.9131. So the area to the right-hand side, excuse me, I put my thing in the wrong spot. The area to the right-hand side is 0.9131. One more of in between. Find the area in between the z-score of negative 1.22 and 1.33. So we want to find the area in between these two lines. So let's start with the z-score of negative 1.22. So we want to look for negative 1.2 on our left column, and 0.02 on top. And you'll see that they meet at 0.1112. So we're going to draw a little sketch. This part is shaded since it's already shaded to the left. If we look at the z-score of 1.33, we'll look for 1.3 on the left. And we'll look for 0.03 on top. And we'll see they collide at 0.9082. So again, this is automatically shaded to the left-hand side. We want to know in the middle of those two. So to find in the middle, we'll subtract. So 0.9082. So take the bigger minus the smaller. And we'll see it's 0.7970 is in between here. So another way we can find probabilities. So let's go backwards and let's find the value of z satisfying. And I'd like you to please change this from 12% to 12.1%. That'll help us in the back of the book at the table. So and we want to shade to the left, and it's automatically shaded to the left when we find the z-score in the back. So this time I want you to look in our table, look in the body of the table, and find as close as you can to 0.121. You'll see that 0.121 is matched with negative 1.1 on the left, and it's matched with 0.07 on the top. So therefore, when we put those together, its z-score is negative 1.17. Let's try another one. Find the value of z satisfying 20% of the area to the right of z. So now we're thinking to the right, it's automatically shaded to the left. So 20% would be 0.2. So to find the left-hand side, we would have to take 1 minus 0.2, which is 0.8. So looking at the body of our table, look for 0.8, and you will see that 0.8 is reflected with 0.8 on the left and 0.04 on the top. So it would be 0.84 would be our z-score. Let's find the value of z satisfying 2.5% of the area to the left. It's automatically shaded to the left, so we don't have to do anything weird. 0.25 is the same as 0.025. So again, looking in the body of our table, you will look for 0.25. You'll see that it corresponds to negative 1.9 on the left, and it corresponds to 0.06 on the top. So when we combine them together, it's negative 1.96 for a z-score. Let's try one more that's to the right. We have find the value of z satisfying 20.9% of the area to the right of z. So we have 20.9% is the same as 0.209, and we want to take 1 and subtract it from that because it's automatically shaded to the left. So the right-hand portion is 0.791. So looking in the body of our table, in Appendix C, look for 0.791. You'll see that it corresponds to 0.8 on the left, and then 0.01 on the top. So when we combine these together, we get 0.81 for a z-score. To find the z-score, we have the x is just a standard number that we're considering. This little mu here means the mean, and then our standard deviation symbol. So Dixie Office Supplies finds that its sales force drives an average of 1,200 miles per month per person with a standard deviation of 150 miles. Assume that the number of miles driven by a salesperson is closely approximated to the normal distribution. Find the probability that a salesperson drives more than. So if we want more than, we're thinking to the right. Then 1,375. So the number in particular that we're looking for and comparing is 1375. We want to subtract our mean. It says the average is 1,200. And then we divide that by our standard deviation. So subtracting and dividing gives us 1.17. So again, looking to the in the back of the table, we're going to look for left side 1.1 and then look at the top at 0.07, and you see that they collide at 0.8790. So this is the part that's shaded currently to the left because we always are shaded to the left. We're curious about more than, so we're curious about the area to the right. So to find the area to the right, since we know that area shaded plus the area not shaded is equivalent to 1, we can take 1 minus 0.8790 and get 0.01210. So this is the stuff that's to the right that we're most concerned about. So the probability that a salesperson drives more than 1,375 miles per month is about 12% that will happen. Find the probability that the person drives between 1,000 and 1,500 miles per month. So we have two z-scores that we need to find because we're curious about what happens in the middle. So let's start with just one of them doing 1,000. So we take the number in question, we subtract the average, and we divide it by the standard deviation. Subtracting, we get negative 200 over 150, so that is negative 1.33. And we also need to find the z-score when we're talking about 1,500 miles minus the average divided by the standard deviation. So 300 divided by 150 equals 2.00. So using our table, we will go to negative 1.3 on the left and go up 0.03 on top. You'll see that they collide at 0.0918. And then we'll do the same for 2.0, so we'll go to 2.0 on the left, and then 0.0 on top, and they collide at 0.9772. So from the previous problems that we've done, we're looking for in between. We want to take 9.9772 and subtract 0.0918 and see that the area in between is 0.8854. So the probability that a salesperson drives between 1,000 and 1,500 miles per month is 88.54%. Find the shortest and longest distances driven by the middle 95% of the sales force. So here, in between is 95%. That would leave 5% left over, so 2.5% would have to be on the top tail, and then 2.5% would have to be on the bottom tail. So when we're looking for our z-score, we're particularly looking for this part, and we're also particularly looking for this part. So we're looking for 95 plus 2.5 is 9. We're looking for 97.5%, which is 0.975. So we're going to look in our body of the appendix and find the left-hand portion and the top portion that matches. So you'll see 1.96. So 1.9 on the left and 0.06 on the top matches. And since we're concerned with the top and bottom, we can say that this is positive and negative because we're looking for, we want to get rid of these portions. We're only curious about what happens in the middle. So now we can use the formula backwards. So that, because we don't know the x number. So we know that the z-score is 1.96, and that's equal to some mileage minus the average divided by the standard deviation. So our goal is to get x by itself. So we'll multiply each side by 150. So 1.96 times 150 equals x minus 1200. Add 1200. So 1.96 times 150 plus 1200. If we multiply and then add, we get 1494. So the highest amount, the longest distance is 1494. We need to find the shortest distance. So instead of using the positive, we'll use the negative 1.96 equals x minus 1200 divided by 150. Multiplying both sides by 150. And we can add, so negative 1.96 times 150 plus 1200. We get a mileage of 906. So 906 is the shortest distance. So 1494 is the longest, and then 906 is the shortest distance. And this concludes section 9.3, the normal distribution.